That last one, I did just about finish this problem, but here's what I was getting at here. Yeah, if we let n go from 1, 2, 3, 4, 5, and keep going on up, we notice that right around 9, you'll see that the n factorial starts to get bigger than 4 to the n to the power. So 9 is the critical place where n factorial is bigger than 4 to the n, which means if we had 8 or fewer questions, we would want the factorial test. We would want the matching. But if we had more than 9 questions, which is probably likely on most tests, we're going to want the smaller number of possibilities, which is going to be the multiple choice. So multiple choice is better than matching once you get up to more than 9 questions. All right, and then the bulk of this video and the rest of our task here is the Form D. Now, mostly the Form D questions are not really a type of question I would ask on the test. I just find it kind of interesting that they try to condense the whole chapter into one question, and they try to make you really think about some of this stuff. Okay, so we're actually designing a game in here, trying to raise money for a local charity. Students have been asked to submit suggestions for games that might be played to raise some of the money. One student has proposed a game involving the wheels shown at the right with the following rules. A player pays $1 for 2 spins. Okay, so it's kind of like rolling 2 dice. If the amount on the 2 spins are equal, the player wins that amount of money. So notice you have 1, 2, 3. I don't know if you can see it on the video. You have the page in front of you probably. 1, 2, 3, 4, 15. If the amount of the 2 spins are not equal, the player wins no money. You just lose your dollar. And thank you for playing. Give the sample space for the result of the 2 spins. So this just means how can they turn out, and this starts to look a lot like dice. You get a 1 and then a 1. That's like the worst way you can win any money, just to get your money back, really. 1, 2. I hope I left myself enough room here. 1, 3, etc. You know what? This is going to take a long time. I'm going to go ahead and pause and fill it up. I'll be right back. And magic wand. Bam! There it is. Okay. So there's a sample space. It gets a little tricky here at the bottom. This is what makes it look a little different than the dice. Because remember, my possibilities are 1, 2, 3, 4, 15. So there's this weird column here where you kind of expect to be writing 5, but you're not. You're writing 15 because that's the last one there. Okay, so there's a sample space. We would expect it to be 25 because we have 5 possibilities and we're spinning twice, so it's 5 for the first, and 5 possibilities for the first, and 5 possibilities for the second. So there's the sample space. Part B, compute the probability. I didn't leave myself much room down here. Compute the probability of winning each amount with 2 spins of the wheel. Okay, so thinking about this sample space, when do we actually win? We win in these situations. You win when you get doubles, basically, and you'll win the amount of what's doubled there. So here I'd win a $1. Here I'd win $2, $3, $4, $15. What's the probability you're going to roll a 1? Or yeah, you're going to get a double 1s. Well, that's 1 out of the 25 possibilities. Do I actually have room to write this down here? Yeah, and really there's no difference for any one of these 5 possibilities. The fact that you're going to win $5 is impossible, because there's no way to roll 5 twice. There is a way to roll 15 twice. It's the same as getting a 1. Sorry, I said 15. That's why I was writing that, but it's really out of 25. There's 25 possible outcomes. One of them is to get a double 15. A 0, well, a 0 is going to happen, believe it or not. These possibilities would all lead you to win $0. All of those and all of these. These are all 0. You don't win anything. Technically, you do win something here. That's what they mean by so you break even, but here you actually lose money. So I think that's what they mean by 0. So that was a lot, right? That was well, I guess 4 in each row, and there's 5 rows, so I guess that would be 20 out of 25. But you know me, I like to reduce. Although I didn't do some reducing today in class on do nows. Anyway, I'm making up for it now. Alright, so part C, show the probability distribution for the result of 2 spins by making a table of values. Well, the possible amount we could win was, you could win $1. Well, we should put a 0 in there, because we need to count for everything, don't we? 0, and we just figured out that for 0 that was 20 of them. You could win $1. We just figured out that was 1. I mean, the rest of these are all going to be 1, right? One way out of 25 you can win $1. Same for all these other ones. 2, there was a 3, right? Other page. 1, 2, 3, 4, and 15. This is, all of these are 1 out of 25. It's 1 out of 25 for double 4s, double 3s, double 2s. etc. Takes a long time to write slowly when you have to write slowly. Okay, and that's good. All these things add up to 1. That accounts for all the different possible things you could win. What's the expected value? Well, of course, if you're walking up to the game, you're thinking, oh man, I'm going to win that 15 bucks. But we're about to find out life isn't always that lucky. 1 out of 25 chance you're going to win $1, so that adds up to the average that way. There's a 1 out of 25 chance you're going to win $2, so that's how that contributes to the average. Basically, it's like saying 3 out of, talking right at the same time, $3 dollars are going to be given away to 1 out of every 25 people, so that costs $3, or $3 is being won once out of 25 times. So that's more money you have to have on hand to pay the winners. I feel like I'm running bigger all of a sudden. Okay, we add up all these fractions. These are out of 25. Well, that really counts for 0, right? So I have 1/25. I'm just going to count to 25th. This seems to be easier than writing up all these fractions. Plus 2 times 1 is 2/25ths. Plus 3 times 1 is 3/25ths. Plus 4 times 1 is 4/25ths. Plus 15 times 1 is 15/25ths, which adds up to 25/25ths. Which is, guess what, everybody? $1. Which means when you go up to play this game, you should expect, on average, to get your dollar back. Basically is what that means. So you're probably not going to be one person who goes up and plays this game 100 times. That would be sort of risky and sort of not very fun. But for the person on the other side of the wheel here, for the club that's running the game, they need to know this. They need to know because every time the game gets played, they're involved in the playing, the money changing hands here. So they need to know what the expected value is. So the question is, are they going to win any money on this game? It doesn't look like it. If they really are expecting to pay out every dollar, pay out one entire dollar for every dollar that they take in, then that's really not going to be a very good game. They may actually lose money. I mean, it's kind of right on the line here of breaking even. So I guess I just answered E. I put think about at the top of this page because I wouldn't ask you an essay type question here on the test, but I think it's good to be thinking about that stuff because it's going to help you as you go through and check, or as you go through and estimate, as you look back on these problems after you've done the test, or to help you with other problems you've done in this review or other review. Do you think this game is describable to raise a significant amount of money? I don't think so. It's looking like they should expect to pay out $1 on average, because they're going to pay some people 2 and some people 3 and some people 15. On average, what we were just finding out was that they're going to pay out about $1 for every dollar they collect. Design a simulation for this game. And okay, now simulation is something we did that was in one of those sections we didn't do. Design a simulation and run it several times. I kind of talked about how to do that in those problems I didn't mean to do, back about the train and that kind of stuff. You could do this as random number generator. You could actually build a spinner and just practice it a whole bunch of times. And then, of course, these results will vary depending on what you actually get. But I'm hoping you would actually get pretty close to expected return of $1. Casinos know all about this. When they design a game, when they design, like all the little fruits that are going to be on the wheels for the slot machines and stuff, and how often all 3 are going to come up together, and how much that should be worth as a payout. It's all about expected values and how much the casino expects to pay out based on how much money they take in. And it's always really close. It's always that they're just barely making more money than they pay out. So that's why they can afford to pay out some people a whole bunch of money. All right, create an original spinner that might be used at the fair, and that's up to you how you want to do it. Again, I'm not going to ask you to do that, but it would be kind of fun. Maybe we'll do that sort of thing as a project near the end of the year after we've done some more probability and stats, and we'll see what shakes out in the calendar. Anyway, on your test, everything in the chapter except for the stuff on simulations, and you know what? I haven't done any writing for a while. This video looks kind of boring. So your Chapter 7 test has got everything in it, 7.1 through 7.5. Is that right? No, 7.6. 7.6 was distributions. 7.7, 7.8 are not on there. I would use this document as review, the practice test I gave you, but also the chapter review at the end of the chapter. Let me look up a page here. Yeah, pages 482 to 485 are not bad. Again, you can omit anything that's in 7.7 or 7.8. All right, good luck, everybody. I'll see you at your test on Wednesday or Thursday.